In this session, we're going to look at vectors in the plane. A vector v is represented by a directed line segment with initial point p at x sub 0, comma y sub 0, and terminal point q at x sub 1, comma y sub 1. So if we look at the geometry here, here's my coordinate system. If this is x0 and y0, this point is P, and over here at x1 and y1, this terminal point is Q. The vector starts at the initial point and goes to the terminal point. So that represents the vector PQ. Now, component form of this vector is found, here's vector V, it's equal to the vector PQ. In the component form, we use angle brackets, and we say x sub 1 minus x sub 0, comma y sub 1 minus y sub 0 is the component form of that vector. So for example, the question says, write the component form of the vector formed with initial point P at 2, comma 5 and terminal point Q 5, comma 9. Take a look at the geometry here. Here's our coordinate system. The point 2, comma 5 is here, point P, and the point Q is at 5, comma 9. Here's 5, comma 9 way up here. Then the vector PQ is there. Now, according to our component form, if we take x sub 1 minus x sub 0, comma y sub 1 minus y sub 0, we get the vector in the component form V would be V is 5 minus 2, comma 9 minus 5. And 5 minus 2 is 3, and 9 minus 5 is 4. So this vector PQ is the same as the vector in standard form 3, comma 4. These two vectors have the same direction and the same length. Now remember we said in a previous session that two vectors are equal if and only if they have the same direction and the same length. That corresponds to say that if vector V is equal to vector W, and we have component form v1, comma v2 equal w1, comma w2. So vector v equal vector w if and only if the components are equal. v1 equal w1 and v2 equal w2. Now remember we had talked about the zero vector as well. The zero vector in component form is 0, comma 0. Now the zero vector has no length. We cannot say what direction it has. It could be in any direction. To add two vectors in component form, say vector v plus vector w. So vector v is v1, comma v2, and vector w is w1, comma w2. Then the sum of those two vectors is the vector form by adding each component. So v1 plus w1, comma v2 plus w2. Now remember geometrically, we said that we added the vectors tail to head. So let's take a look at an example here. Question says, let v equal 3, comma 4, and let w equal 1, comma 5. Then we want to find v plus w. Well, according to the component form, we would have 3 plus 1, comma 4 plus 5. So simplifying, we'd say v plus w is equal to 4, comma 9 in component form. So let's look at the geometry again. Here's a coordinate system. The vector 3, comma 4 is right here. The vector 1, comma 5 has terminal point up at 1, comma 5. So there's the vector W. We wanted to add vectors tail to head. So if I take the tail of vector W and append it to the head of the vector V, that would be the vector W, and completing my parallelogram, vector V again. And remember the resultant was formed by going from the origin here across the diagonal V plus W. And if we look at the component form of that, it was 4, comma 9. So here at 4 units and 9 units up. So there's the point 4, comma 9. That forms the terminal point of that vector V plus W. Now let's look at scalar multiplication again. If we let C be any real number, let V be a vector, then we defined the vector C times V as a vector in the direction of V, but length, the absolute value C times the length of V. So remember that was a scaled multiplication. We can think of it as a contraction or dilation. Now component form, take the scalar C times the vector V1, comma V2. The result of this multiplication is the vector CV1, comma CV2. For example, if we take the vector W as 1, comma 5, then the vector 3 times W has components 3, 15. And so if we stretch that vector W by a factor of 3, we would see the terminal point up at 3, 15. And what would the vector negative 2v look like? Well, negative 2v would have components, and again, if we use the same v, 3, 4, then negative 2v would be negative 6, negative 8. So it would have opposite direction and twice the length. Vector negative 2v would be down in the third quadrant, way off there to the left.